Hello everybody, my name is Ethan. Welcome back to the channel where today we are going to be hopping back into the machine learning course on Codecademy. In the previous video, we finished up this machine learning fundamentals part of the course where we ended up doing PCA and the PCA quiz and finished out this nice unsupervised learning algorithms. So after finishing that big section, we are officially over 1/3 of the way through the course. I'm really happy about that. It doesn't look like it, but this machine learning fundamentals was definitely the biggest part of the course. A lot of it is a little bit more split up, and I do have a little bit of it already done. So one of the things that you're going to notice is when I click into this, it's going to show that I have a lot of this already completed. And that's because it's the introduction to classes and object-oriented programming. Now that is something that is quite important. Obviously you should know what classes are in Python. At the beginning of these courses and these videos that I started, I said that you should probably have a little bit of knowledge in Python just so that you could follow along and we're not starting completely from scratch. So I'm not going to cover this classes part of the video. I could go back and look through all of this, but I'm not going to do that. Just because classes are something that is pretty integral to the Python, I guess, learning in general. So you should already kind of have a grasp of object-oriented programming. I'm not saying you should be a master. I'm not saying you should understand everything about classes, but having a little bit of that knowledge is helpful. And it's going to mean that I'm not going to actually go into object-oriented programming. I'm actually going to skip ahead to functional programming in Python. And that's because, again, I've already completed this, so you're going to see all my past work. I completed it months ago now. But after this, we're going to probably try and get through all of this today, hopefully. We'll see what happens because sometimes takes a little bit longer. So it might end up just being the functional programming and then logging in a separate video. But for right now, I'm going to just jump into it. Again, sorry if you're looking to do some introduction to classes in Python. Please go watch somebody else's Python video about that. If you missed any of the machine learning stuff that I did in the previous sections, the first 12 videos on this channel of machine learning are going to cover this machine learning fundamentals chapter. So now we're going to go into the software engineering for machine learning / AI engineers. I've already done the welcome intro just because that doesn't cover any material. It just covers basically why you're taking this course, what's helpful in it, what you're going to actually learn, and then also stuff like who you're going to be learning it with. You can obviously go check the forums, obviously, stuff like that. So I think I've covered all the bases there, and I think we can get into the functional programming in Python. So if we go into the introduction to functional programming in Python, we'll see that in this article, we'll explore the concept of functional programming, including its differences from object-oriented programming. So again, miss object-oriented programming. Go and check it out on a different channel because I don't think I have one on my channel. I do have a classes video, but it's in C#, so maybe not the most helpful. This article is divided into the following sections. There we go. All right, so introduction to functional programming. Functional programming is a programming paradigm in which code is structured primarily in the form of functions. The origins of this programming style arise from branches of mathematics known as lambda calculus, which is the study of functions and their mathematical properties, in contrast to the popular object-oriented programming and procedural approaches. Functional programming offers a different way of thinking when solving a problem. Let's explore how program solutions in functional style. So functional versus object-oriented. In object-oriented programming, or OOP, you structure your code based on the concepts of objects. The commonly used OOP objects, such as Java or C#, we create a template for an object using the keyword class. We instantiate it using the keyword new. These objects contain fields that store data and methods that can manipulate data. In the style, an object can be passed as an argument in the function of another object. In functional programming, you create a solution by structuring code mainly using functions. Functions are first-class citizens in this paradigm, meaning we use them to store and manipulate data with limitations similar to the objects in object-oriented programming. In functional programming, functions can either be passed in as arguments to other functions and can be returned by other functions. Declarative versus imperative? Declarative versus imperative?
Imperative.
Yep. Before we learn the advantages of functional programming offers, we must discuss the differences between imperative paradigm and declarative paradigm. Imperative programming solves a problem by describing the step-by-step solution. Imperative programming is concerned on how to solve the problem. In contrast, declarative programming relies on the underlying framework or programming language to solve a problem. The programmer's only task is to describe what the problem they would like to be solved is, and then declarative programming is concerned with what problem to solve. An analogy, consider the example of obtaining a cup of coffee. Imperative programming would be the equivalent of you making the cup of coffee yourself by performing the following tasks, right? Declarative programming is the equivalent of going to your local coffee shop and telling the barista, I'd like a cup of coffee with 1 teaspoon of sugar, please. The barista prepares your coffee, gives you the cup, and then you drink it without concerning yourself with the details of how it was made. For a programming analogy, consider the following example of having to sort a list in Python. Imperatively sorting the list would have you implement a sorting algorithm like this. Or, if we're just doing declarative, we could just do list.sort. Which style of programmer follows may depend on their goals. If you're looking for concise code that gets you an answer efficiently, you might go with declarative approach. If you're working with other people and want to ensure that your code is easy to follow, you may choose a more imperative style. OOP and procedural programming follow an imperative approach. Functional programming follows a declarative approach. Writing functions in functional programming. As we said in the introduction to this article, the central concept in functional programming is of a function. However, there are requirements that a function must adhere to when writing one. The first of these requirements is the function must be deterministic. That is, for any given input, the function must return the same output when provided with the same set of inputs. Let's illustrate this with the following example of an add function. We have an add function that says that takes in 2 parameters, x and y, and we return x plus y. This function will always return 7 if add is equal to 5 and comma 2. Another of these requirements is the functions must be free of any side effects as possible. A side effect is when a function alters some external variable. The goal is to minimize, not eliminate side effects. It'll be impossible to eliminate all side effects in a function because a program eventually must have an external effect to be useful. A pure function is defined as a deterministic function with no side effect. Consider this example. Answer is equal to 0. We then have the add function that changes the variable of answer. So this function definitely has a side effect. The add function defined in a way that the side effect, because it alters the external variable. To make a pure function, we should write it as this. Answer is equal to 0, define add is equal to this, and then we would just reset it as answer is equal to add x plus y. Notice how the add x plus y function no longer alters the answer variable during its execution. Also, the variables x and y only exist within the scope of a function. Operating on them allows the function to have no side effects. For reusability, a function should always have relevant parameters passed in and should not rely on global variables. Consider the example of a function app that replaces the first and last word and last element of a list with a 0. So we have a list here. We have an app that will look at make sure that it's a list, and then it'll look at the last 2 variables, set it equal to 0, and then return the list. So if we have 0 list is equal to app, writing a function in this way makes it dependent on an external list called list. The function is not reusable, as using it elsewhere requires list to be defined externally. While it is not reusable, app is still considered free of side effects as it reads, but it does not modify the variable list. A better way to write the function would be to pass in the required list variable as an argument like so. So we have L. We create a list of L variables, right? Then we change the last one to 0, first one to 0, and then we can use the app.list and pass in the actual list. The app L function is free of side effects and now is also reusable. We care about pure functions because as our programming gets more complex, we want to avoid incorrect altercations of the external variable. For example, if we call functions from different threads using running concurrently, we need to construct our functions carefully to avoid side effects. Following the functioning programming paradigm is a great way to keep code clean and efficient and simplify testing. Using recursion instead of loops. To execute a section of code repeatedly, object-oriented programming uses a while loop or a for loop. Loops do not adhere to functional programming style because they maintain an external counter which is altered from the inside of the loop side effect. In functional programming, use recursion to execute code repeatedly. So recursive functions are typically written in the following style. The classic example is the computation of the nth Fibonacci number done like so. Fibonacci n. If n is less than or equal to 1, return 1. Return Fibonacci n minus 1 plus Fibonacci n minus 2. Passing functions as arguments to other functions. So in traditional object-oriented programming, you can pass objects as arguments to a function. In functional programming, you can pass functions as arguments to other functions. This is known as treating functions as first-class citizens, a term you may often see in the industry. Let's take a look at an example. So we have an add function, a subtraction function, and then a times function. And then we say times 3. And we also have a function as a parameter here. So it will return 3 times the function of a and b, and that will use this function then. The code defines a times 3 function that multiplies the result of an add or a subtract function by 3 and returns the value. The times 3 function also allows the passing of another function that accepts 2 parameters and returns an integer. Functional programming promotes the concept of brevity when writing code. It's important to be concise and write functions in as few lines as possible, as long as readability is maintained. We can also pass a function to another function by writing it in the argument using a lambda. We can shorten the previous code using a lambda like so. So we have a function called divide 3 times, and we can use the lambda. So we have our a and our b. And then our lambda function, right, with x and y, where they add together, right, versus subtract together, right? This will output the same result as the verbose implementation from earlier. Lambdas are a great tool, and they allow a programmer to write a function when maintaining the flow of ideas. In summary, functional programming is a powerful paradigm that confers many advantages. In this paradigm, we structure solutions in the form of functions. Functional programming differs from object-oriented programming, and it follows a declarative style as opposed to an imperative style, leading to code that is shorter, easier to test, less prone to bugs, and well-suited for multi-threading applications. Many languages allow for implementing the functional programming. One of them is Python. Very cool. So, introduction. Get ready to be the master of functional programming. This content branches off some content you may have already run into in our intermediate Python. We'll look at tuples, lambda functions, map, reduce, filter, and working with JSON and CVS or CSV files. All right, immutable data types. Immutable data types are important to use in functional programming as they offer advantages such as thread-safe data manipulation, preventing programmers from accidentally changing a value. We could create a tuple of tuples with a mix of data types like the following. This is a great way to store our mixed data. However, there is room for improvement. The student tuple contains records of student in a CS class where each tuple stores the student's name, age, and grade they received. Defining a tuple in this matter is prone to errors as it requires the programmer to remember the position of each piece of data in the tuple. Instead, we could use the named tuple data type from the collections library like so. So we create a class called student, where the name tuple, student, and then we have all of the other stuff. Then create tuples for the 3 students by just using this syntax where we have Scott, Nicole, John, student, student, student. Perfect. All right, we can access the information then by printing age, name, and grade, right? Take note that the name of the tuple and the variable that it stores in the tuple must be identical. We can package the 3 student tuple together into a tuple called students like so. The programmer is no longer required to remember the position of each piece of data as they can refer to it using the property name. All right, it wants us to create a named tuple called country. So we're going to say country is equal to named tuple. Tuple. And inside of the named tuple, we want obviously first country, and then we will do a comment, and then we'll start the next list here. It wants to have name, capital, and continent as fields. Perfect. All right, create 3 tuples that use the following information. France, right? So we'll do that. We'll start with France is equal to country with the variables. I think we just do this, right? Yeah, that's what it is. Don't want to mess that up. Name, France, capital, Paris, continent, Europe. We'll do the same thing with Japan is equal to country, Japan, Tokyo, and then Asia. Then we have Senegal with the 3 fields that we've been doing here. It's Dakar. Sorry, I'm not the biggest geographer myself, and it's on the continent of Africa. And I ended up putting pairs instead of pays. Pack all 3 continents into a country and a tuple name. Country is equal to France, Japan, Senegal. Cool. Review of lambda functions. Lambda functions are crucial in functional programming as they allow the production of neat and concise functions that require other functions as an argument. You should be familiar with lambda functions from our previous courses on Python, but if you're not or would like a refresher, this exercise will serve as a brief review. A lambda function is a short anonymous function that can accept several parameters but only returns one value. Lambda functions can be stored as a variable or defined inline in the incepting function. Consider the following example. We determine the cost of a 2-dimensional sheet of metal by multiplying the price per square meter times the area of the sheet. We can cut the sheet into either a rectangle or a triangle. To model this, let's write a general function in Python that calculates the price of a metal sheet. The function will accept 3 parameters, price per square meter, tuple of dimensions, and then a function to compute area. Recall from geometry, these are the areas. Writing the function without lambda, we have define rectangle is equal to base times height, define triangle is equal to base times height times 1/2. And then we have the total cost. We have the price per square meter, the dimension, and the area function. We do price times square meter times the area function, whichever one we want to put in. And then if we had a triangle, it costs 75, or a rectangle would cost 75, and then the triangle would cost 84 because it's a little bit more expensive, right? To make the code shorter, we can replace rectangle B and H and triangle B and H functions with lambda, like so, right? Lambda functions can be stored in variables as well. Lambdas are a very powerful tool in Python. However, they have a drawback and they're only suited for short and fast functions. Long, complicated functions cannot be written as lambdas. All right, let's complete the odd or let's remove this statement here to start this odd or even function. The body of the function will return even function n if n is even and return odd function n if odd, right? So, body of the function will return. So we'll say if n divisible by 2 is equal to 0, return even function n. I think I'm doing this right. Do this actually. Yeah, my bad. So it wants me to take these and make them into lambda functions. So the first one we'll call square, and set it equal to the lambda function that takes in an x, and it will multiply that x times x, right? Then we'll take a cube function that equals lambda x times x times, I guess we could also just do x to the power of 3 just to cube it, but we'll also just repeat what it looks like up top there. For this checkpoint, odd numbers are to be squared and even numbers are to be cubed. Create a variable called test and set it to even or odd with n being 5 and pass in square and cube in the appropriate locations. Okay. So odd numbers are to be squared, even numbers are to be cubed. Test variable called test is equal to odd or even with the variable 5. Even function, we want cubed, so we'll cube and then square. Cool. Review filter, map, and reduce. In this exercise, we'll review map, filter, and reduce, higher order functions provided by Python. These functions accept an iterable and processing function as arguments and return another iterable. Similar to the exercise on lambdas, this section should serve as a refresher. You may recognize these functions from intermediate Python content. If you need more quick refresher, if you're stuck, we recommend you review this article as an aid. The first function we'll look at is filter, which converts the following imperative code. So we have a list of numbers here, or actually a tuple of numbers, sorry, and then we have filter values is not a higher order function. I see. They're just showing what it looks like in the imperative code versus the declarative. I see what they're doing. Iterable has two parameters known as the accumulator. It is the accumulator to recursively process the contents and reduce them to one value. Okay. So I'll add this print line first. I'm going to use this lambda expression. God, I hate my chair sometimes. I need a new one really bad. Amazon Prime Day, though, may be worth looking into because the wheels are all messed up. Higher order functions are powerful tools. Yeah, it just wants me to use the filter function, which is up here, where I divide x divisible, where take x. Okay, is equal to filter lambda x, where x divisible by 2 is equal to 0. Okay, map to multiply all the elements by 3. Cool. What was it in this one? We have to import it, it said. So I did not print the result. Okay. Mapping a filtered collection. In this exercise, we'll see how to combine the map and filter functions. Conceptually, if you're working with a collection of items and find yourself saying, I need to map only the values that have property X, you'll likely need to use map and filter together. In English, I need to map filtered values. Translates to Python like map, mapping function, filter, predictor, predicate, iterable. Let's take a look at our example. We have a tuple representing the records of students in various math classes. The tuple will be structured in the following way. As an example, student Peter B will be a student named Peter who received a B in 101. If you want to register who receives a grade of B or better in their respective math class for a special advantage math, advanced math course, Math 201, to create a record. The initial grade of the new tuple will contain the letter X and represent that it is not yet defined because the student has not yet finished Math 101. We can do this in Python like first create a named tuple. Create records. Then we use the map to create a new record of consisting of their name. So we make a new name, lambda s, student s dot name, x, filter lambda q, q dot grade is less than or equal to b. Then it removes the students with grades less than B, the less than appears because the character A is lower than B in the alphabet, how Python compares characters. I see. Given this tuple nums, multiply so it will, we'll first do map. Map lambda is equal to, so it wants to multiply values that are greater by 10 by 2. tuple to generate all the values. Oh, I actually did it right. That's pretty crazy. I'm just so goated like that. Convert the following code from imperative style to the declarative. Here nums represents the tuple provided in the workspace. Save your result in a variable called functional way. Print your answer using the following code. So first, it looks for all of them and sees if they're divisible by 3. So the filter is divisible by 3. If we kind of back it up, we know there's going to be a filter where lambda x is going to be x divisible by 3 is equal to 0 nums. But now we just have to put this in a mapping. What happens in the mapping? Looks like we multiply it by 3. Oh. We just multiply it by 3. So we can say map we do this, we do another lambda x times 3. I want to say that works actually. Very nice. If I had to guess, this is what it's going to be in the hint. Very nice. Is there a reason why they use y as opposed to x? Not sure. Reducing a filtered collection. In this exercise, we'll explore how to reduce and filter together. Let's consider the following example. We have a tuple representing menu items for a fictitious restaurant, the Codecademy Steakhouse. We wish that the least expensive appetizer on the menu. We can express this process by a sentence: filter the menu for appetizers and return the least expensive one. Let's do this imperially. First, the starting code. Click to see the starting code. Cool. So we just have all that stuff. Imperative solution, filter the menu and return the least expensive one. Filter and reduce, like first we do reduce x and y, x if x.price is less than y.price, else y, filter x.dish type is equal to appetizer. Okay, so it only selects appetizers on the menu, and then it looks for the cheapest one by using this little string of code here, right? In the reduce function, if the lambda x comma y, x if price is less than y price, else y returns the cheaper of 2 menu items compared to their price. The filter function returns an iterable with all the menu items that have an appetizer as dish type. This iterable is then passed into reduce to be processed by its lambda function. Combining these two functions converts the imperative code into a one-line solution. All right. Given the extended menu for it, filter and reduce, find the most expensive dish that is an entree. Assign it to a variable called entree. So first we do entree, and we're going to reduce our thing, and it wants the most expensive dish. So we'll do lambda x and y, where it's if x.price is less than we do yeah, I remember now. So we'll do x if x.price is greater than y.price, else y. Then we'll do and add in the filter statement where we only want the name of the dish or the dish type to be what's it called? Entree. Entree. and we will use the menu item, menu. Cool. Looks like the porterhouse steak is the most expensive one. Next, we're going to use filter and reduce to find the least expensive dish that is either a side or a salad. So we'll create a new variable called least expensive. It's equal to the reduce function, lambda x and y, and we're going to use the same kind of function where x if x dot price is less than y dot price else y. Filter lambda x. We'll print x if x dot dish type is equal to salad or x dot dish type is equal to side using the menu. Cool. So it looks like the mixed green salad is the least expensive salad or side. And if we kind of look at it, it's kind of looking that way, right? We have the Caesar salad, 15, 10, 35 for a fucking side of Codecademy potatoes. I'd be throwing a fit there. Reducing a mapped collection. In this exercise, we'll be focusing on the benefits of using reduce and map together. Consider the example of having a dictionary representing the cost of an item sale called cost, which maps an item to a tuple containing the total number of units sold and the price per unit. A dictionary would look like this. Wish to find the total cost of all items sold. And if this were a list or a tuple, we could simply apply the reduce on it to find the sum. However, this would represent a problem if we tried to attempt this on a dictionary. The lambda provided to reduce requires that the two parameters and the return value be of the same type. For example, in lambda x and y, x times y, the x and y return all types that are integers. As you can see, they cannot reduce a dictionary to a number because they are not of type. We must process the data in the dictionary first. We can use a map to iterate through the dictionary and compute the cost of every item sold. We can potentially store this in a tuple and then reduce the tuple to a single number, the total cost. Note, when passing a dictionary as an iterable, the function will iterate through the list of dictionary keys. Let's look at an example with the following. Okay. Costs is equal to shirt, shoes, pants, socks, total cost. Lambda x and y is equal to x plus y, and then we map it with q, cost q0. Pass into map along with the lambda cost q. The lambda function takes the price tuple and generates a total cost per item by multiplying the number of units sold by the price per unit, GBTP, the lambda in the function. We could have done this using the name tuple, but we excluded it for brevity using map to press dictionary in the JSON format, which we'll see in a later exercise. We will not, I don't believe we will be moving on to logging today. The dictionary provided represents the number of given fruit sold over 3 days. A dictionary item is amount sold on day 1, amount sold on day 2, amount sold on day 3. To map or reduce, find the notable sold stars and answer called total fruits. So we do total fruits is equal to, first we, I guess, reduce, and we'll do lambda x and y goes into x plus y. The q is equal to, I'm going to just call it t, is equal to, what do they call it, fruits. Fruits with the t and the 0 plus fruits with the t and the 1 plus fruits with the t and then the 2 with then it passing fruit. I'm not confident. Yeah, I did not actually print it out, to be honest. Oh. Well, I actually ended up doing it correctly. I was pretty confident in this right here. It was just this that I don't understand. Lambda. We reduce it by just adding x and y. Goated. Combining all three higher order functions. Now that you've learned it, let's combine all three. In this Python exercise, we're given a record of items representing a dictionary. We're interested. First, map the individual items to a cost. Then eliminate, filter out all the items that cost more than. Then reduce. To do it, we would do reduce first, then filter, then map. Okay. Oh my, the focus of the code is this, obviously. The first computes the total of each item using map, right? So it looks like it's pretty helpful to just work inside out, right? So you start on the most inside function. We want to first map the items to their individual cost by going inside to that function or that tuple, right? And we grab the cost of everything and we multiply it. The filter is used to eliminate all items that cost more than 150. R is less than 150. Right? That one makes sense. And then the reduce is used to compute the total sum. Alright, given the record of item sales costs, find the total cost of item that costs more than 150, answer total. Alright, so what we're going to do is we're going to say total is equal to, and we're going to work from the inside out. So first we're going to map all items to find the total cost. To do this, we're going to use the lambda expression using x as our I'm going to use t to keep it consistent on what I've been doing for total. We're going to go into costs and then t. And then we'll do T0 and then plus costs T1 using the costs function. Then once we're done with this one, I'm going to wrap it in a big thing here. And we are going to use filter. I'm going to go back inside of it, another lambda function, lambda x. We're just checking in this case that x is, what is it, costs more than 150, costs more than 150, and then we can throw in the map. Finally, we'll do one more wrap here, where we wrap the entire thing one more time. This time is going to be in a reduce statement, and we're going to reduce based on the fact that on the total, right? So we want to reduce, with x plus y. So we would need x and y, x plus y, filter. Looks like you have an error. This might end up actually being, what's it called? Number of units sold. So instead of multiplying the mapping, we're actually just was adding. Perfect. So looks like the total was $460. Given the tuple nums, use map filter and reduce to find all numbers less than 10 and add 5 to them, and then find their total project. Oh, using nums. Okay, so this is a separate one. Okay, so product is equal to, we'll start again from the inside out, starting with the map function. We're going to say lambda. We're saying we were going to add 5 to them, right? So we will say lambda x is equal to x plus 5, right? Yep. So then we wrap this in a filter statement with the same lambda. In this case, though, we want over the all numbers less than 10. X is less than 10 with map. And I forgot to do, in this lambda function, I have to add nums. Then we wrap it one last time using the, using the reduce function. And in reduce, again, we do the lambda expression where we do x and y. But in this case, we want x times y filter. Did you use filter to find all numbers in nums that are less than 10? I think I did. Add 5 to them and find their total product. Let's take a hint. Maybe it was different. It was mapped add 5 to all filtered values. Alright, maybe we can rewrite this. We'll start with the filter instead. So we filter all values that are less than x is less than 10 using nums. We can then wrap this in this, and then we'll say map, and then we'll say lambda x x plus 5 using the filter. Then we'll wrap this, reduce, and we'll do lambda x and y is equal to x times y. There we go. So it wanted me to use the filter statement first. I guess that makes sense because if we use the mapping statement first, it's going to add 5 to all of them. A lot of numbers are actually going to go up past 10 in that case. So importing data from CSV file. Functional programming is widely applicable in the data science domain as higher order functions can be used to process data efficiently. One of the most common formats for a data file is CSV, comma separated value. In this exercise and next, we're going to work with some data stuff. So import CSV with open sol.csv new line as CSV file, and create a reader object and iterator that will read the file. A CSV file often contains millions of lines of data. Importing the entire contents of a CSV file is impractical and occupy too much RAM, resulting in poor performance. To avoid importing all the data at once, reader is an iterator object that maintains a pointer to the file and iterates through a file when next reader is called. We create a name tuple to represent each record. So we say house is equal to name tuple, house, index, square footage, year, list price. We use the map function to read a line of data and store it in a tuple. Incoming data arrives as list of strings regardless of their intended type. Therefore, we must cast each element to convert it into the proper type, done like so. We'll map it x house, and yeah, there we go, that makes sense. Because the amount of the type in Zilla file is small, it'll be okay to create a new tuple called houses and populate it with all the individual house populated tuples like so. Next exercise. So it wants me to create a named tuple called tree. Index height volume create an iterator called mapper that will map each of the records to tuples of type tree. This is really bad because they should just teach you pandas, because pandas, reading CSV files with pandas is just 1,000 times better. So it wants me to create a mapper object. I don't know. The map function creates an iterator that can be used to store a tuple like so. Mapper that will map. So we say what? Mapper is equal to map lambda x house, not house, sorry, tree. The index is in inches, so what? It should be a float. Which would tell me. I guess we'll just do float x 0. I don't know how there are this many things already. Might actually want to just check and see how this looks. Tree. Why an int? Inches is an int, so you cannot go to ½ an inch. Okay, can't do a ½ an inch, that's fine. Int x, comma 1. Int x, comma 2. Int x 3. Reader. Okay. Expected trees to be defined. I see. Do you want me to, let's view the solution once again. Yeah, I wanted everything inside the with statement for some reason. Oh boy. See, this is why I didn't want to do int. I wanted to do float instead. Line 12. Does it give me the arrow? No. Line 12. I mean, okay. It should be float. All of these should be float. Yeah, that's really strange because they just had one of them as float. It's like you can say inches is not a float, but this inches is. So that's what doesn't make any sense. This inches is not a float, but this one is a float. This one's not a float. This one's is a float, but in feet squared or cubed, no siree, not a float. Processing data in this exercise, you can see how to process data that's stored in the CSV file and working with a file that contains a large amount of data, generating every possible record using tuples and efficient. Recall the previous exercise that map returns an iterator that we can use to bring data. We can apply the higher order functions to this iterator to process the data and only bring relevant sets of information. For example, you can do this by applying the filter with lambda q2 is greater than 1955. Okay. Say we want the most expensive home built. Reduce this to something like this. Filter map and reduce it. Create a tuple called trees. T is equal to tree bless it. Create a variable called widest. Insert in the record of the widest tree is. You may want to print the answer to see which tree is the widest. Okay. Like, I don't understand. Are we putting it inside? I guess we are. Never mind. Okay, so we filter that. And wrap that in a reduce. But I'm confused on what we would even put in the reduce. Lambda x. I don't know what the fuck to put in there. Reduce lambda. I'm confused. That's a filtering statement, is it not? And cool. Processing data from a JSON file. We find ourselves in a situation where we're looking at JSON data. The JSON format is preferred way to structure data so that it be transmitted over the internet. An API can usually respond to data formatted into JSON. We can process JSON data using the higher order functions we've been working with. However, unlike CSV, we cannot, as an iterator, when we read JSON file, the file's entire contents and read are stored in a Python dictionary. If a JSON object contains another JSON object, the dictionary will contain another dictionary. Unfortunately, the JSON library in Python does not provide a method to produce an iterator that we can use to read in. Similar to CSV, we will have to work with type. To illustrate, which contains the following data. To work with the JSON file, we must open it and read it as we did for the CSV file. So again, we first import it with open cities JSON as JSON file. Cities is equal to JSON.load JSON file. In the JSON file, there's an object called city that contains an array of JSON objects containing data relevant to a particular city. When the JSON file is read, it will produce a dictionary containing one entry, a map between the string city and a list of dictionaries that represent data relevant to each city contained. The dictionary will be in this structure. Data formatted this way is hard to read and susceptible to errors when using it. It would be better to use the map to store the data as a named tuple. Okay, so what do we do here? Cities equals data.city. Cities list is just the cities. Lambda is equal to city x. Store all cities that are on the continent Asia. Make sure to print out the result. Filter function predict. Should check all cities with the continent field set to Asia. So Asia is equal to filter lambda x if x dot continent out of the cities. Oh, X. How is this not correct syntax? What is wrong with the comma? I'm confused on what's wrong with the comma. How does it know what to grab from? I'm gonna look and it's gonna be like something stupid as fuck. Oh my god. What is it? What is the issue? It wants me to wrap a tuple. It in a tuple. Sure, makes sense to me. Store all cities in the continent in a tuple called Asia. Make sure to print out your result. Find all westernmost cities in the Asia tuple and store it in the west variable. Make sure to print out your result. Note the westernmost country is 1 north longitude is the lowest number minimum of city coordinates 1. What? Probably use reduce here, no? The reduce function should be used here. An example of where reduce is to find the minimum. So we use the reduce to say reduce lambda x and y, right? Where if x dot coordinates is less than lowest number, right? So y dot coordinates equals y. X of coordinates is less than else y. And then we would put in cities. Let's see what they did. Okay. Minimum of, I see. Why Asia? Why? I gotta just read, bro. Review. You can read through this. Learned a lot. Probably have a project now. And yep. And then there's something else. Is that a quiz? Why is there a quiz after this? Okay, let's first do the project, I guess. To further your understanding of functional programming, you'll create your own higher order functions and then use them to process data from a CSV file. Our count, average, predict, iterate, the average function, iterate function, reduce. Let's start by creating the count function. Inside the count function, write a filter function that will iterate. Will filter ITR based on predictive. Nah, I think I'm good for today, to be honest. I know I've been skipping a lot of the projects, but some of them just seem so fucking stupid. Sorry to say that, but I'd rather not sit here for another 45 minutes trying to figure out what to do in this project when they don't really help you through it at all. Which is fine. I mean, it's just something that I just don't want to sit here and do. Write a filter, like ITR, something we did not, the collection containing the element of interest. That's it. I don't get it. Okay, whatever. Alright, complete the following code that computes the sum of all the numbers and nums that are divisible by 3. Okay, so sum of all numbers. The last one's going to be reduce x plus y. And now we just need to know, are we filtering? Yeah, we're filtering. Filtering that they are divisible by 3. Complete the function that squares all even numbers. Okay, and a tuple called nums. So it's going to first want to check that. So it's going to map, it's going to square all of them. So square all of them. Even numbers though, so we'll have to filter here and check if x divisible by 2 is equal to this. Yep. To read in records from a CSV file, a reader iterator must be created first to represent a data using a named tuple, which higher order function should be used on reader. To represent the data using a named tuple. We map it, yeah. Given an entry about a car that contains the following fields, name, color, year, how would you represent this using a name tuple? Car is equal to name tuple car, name, color, year. This one. What is declarative programming? A programming style that describes what problems to solve. Like the top one. The programming style that describes nope. Describing similar nope. Nope. How would you use map and reduce to implement the following loop? So for I numbers. So S is, it's not going to be the top one, but S is equal to, first you're going to map and square all the numbers, right? So H is equal to H squared, yep. H is equal to C squared, H equal to squared, H. I don't like that one. I like the map. I like this one and this one so far. I don't know it's adding a Z though there, so I'm going to take this one. What data structure is used to represent dictionaries? How would you write the following code as lambda function? Takes in two parameters x and y. It says x squared plus y squared is equal to z, so okay. Functional programming follows the style of imperative programming. False. Given the following code, what is the type of reader? Type iterator. Close enough. One more. Given the tuple number of names, complete the code that finds the numbers that are greater than 10, squares them, and then finds the minimum of those numbers. So, the first one is going to find if it's greater than 10. So we're going to have to use a filter, lambda, that's greater than 10. Then it's going to square all of those numbers. So we're going to have to use a map. And we're going to have to use lambda k is squared, comma, filter. Yep, makes sense to me. Last one on the outside is going to be reduce. We're going to reduce with lambda x and y. We're going to say x if x is, and it finds the minimum of the numbers, x if x is less than y, else y. Very good. 89%, pretty happy with that. Let's continue learning. Okay, that's going to be the end of this video. Ended up going a lot longer than I thought it was going to, over an hour for this one. Usually we haven't hit that since we've been doing C#. So that was pretty good. So thank you guys so much for watching. If you did enjoy, please be sure to leave it a like, subscribe, and I'll see you in the next one. Peace out.